in biology, we engineer with a very new kind of substrate. I mean, people have been engineering passive materials like wood, metal, Legos for thousands of years. Then we had active matter and now even computational matter. But I want to talk about something very special, which are agential materials. And this is what happens when you engineer with life. So to understand to what degree your material is an agential material, meaning from an engineering perspective, to answer this question, these are the kinds of things you have to ask yourself. How much of what it does do I not need to micromanage? How much autonomy does it offer? How much is what I do basically communication as opposed to micromanagement? How much of my task is reverse engineering as opposed to engineering? That is understanding and managing what the system is already doing. Very importantly, how much more do I get out than whatever my materials or my algorithm put in? I have to understand the intrinsic motivation and the agendas of the material that I work with, and what kind of tools, all the way from rewiring to some sort of high-end psychoanalysis, are going to work best for me, right? And the living matter is actually very high on all of these kinds of metrics. And so for the next few minutes, what I want to do is show you some special properties of living matter. As a biologist, and in particular a worker in regenerative medicine, one of the things we're most interested in getting to is something I call the anatomical compiler. So someday you will be able to sit in front of a computer, you will be able to draw the animal, plant, organ, biobot, whatever. You'll be able to draw the being that you want. And what the system would do is compile that down to a set of stimuli that would have to be given to specific cells and groups of cells to get them to build exactly what you draw. And it could be anything. It could be things that have existed before. It could be completely novel things like this three-headed flatworm. This is the end game for understanding how to interact with the material of life in biomedical settings. Now, it's obvious why we need this. If we could do this, if we could tell cells what to build, we would be able to basically abolish birth defects. We would be able to regenerate after traumatic injury, reprogram cancer, defeat aging, and all of that. Now, you might wonder, why don't we have this? You know, you've been hearing about genetics for decades. Molecular biology, biochemistry have been going very strong for a long time. Why don't we have this? Because we don't have anything remotely close to this. And that's because this anatomical compiler is not something like a 3D printer. It is not for micromanaging the cells or the molecular pathways inside of them. It is a translator. It's a communications device that's designed to take the goals of the engineer or the scientist and translate them to be the goals of the goal-directed living system. That is a very unconventional view of biology. That is certainly not how most biologists think about it. And that, I think, is the barrier that's holding us back from transformative regenerative medicine.